Hi students, today we will discuss one topic, collisions. Collisions means what? Two objects are going to bombard each other, or it is going to get collided. You might have seen caroms, you'll striker will be there and you will be pushing the striker, it will go and it will hit to the coin. So both it will go in the different directions. Like that, snookers are there, snooker balls, one ball we are going to hit it and other ball is going to it is going to get collided, then it will go like that. Like that, air molecules also will continuously will get collided, even vehicles also will get collided. No? So this bombardment only will call it as collisions. Well, what will happen when these two objects are going to get collided, right? So basically, ideally we will study so in the collisions now. Let us see what will happen in the collisions. No, suppose let us take one objects, like one ball. So assume that they are mostly rigid one now. Therefore, M1 is moving with U1 and another one more ball is there. Therefore, M2 it is also going with U2. Both are going in the same direction. If they want to get collided, what will happen now? This should go slowly, this should go faster. So what will happen now? It will go and it will hit it. So when it is hit it, what will happen now? So this first ball is hitting to the other second ball. So this first ball, what it will do now? If this first ball, it will push this second ball, and this second ball, what it will do? It will push the first ball. This second ball, what it is doing now? It is pushing this one backward, and this first ball is pushing towards the forward. Therefore, after collision, therefore this it will go forward with greater speed, and this one will slow down. That means the kinetic energy of this ball slightly loss of kinetic energy, it is given to the other ball. So this is like action and this is like a reaction now. Therefore, here Newton's third law is applicable in this one now, right? In any collisions. So what will be the total external force now? Total external force, there is no external force while it's got colliding onto this one. No external force. If external force is 0, so therefore initial total momentum, how much initial momentum is there? After also, therefore the momentum will be, total momentum will be equal. So this is only we'll call it as like a law of conservation of momentum. Law of conservation of momentum will do one separate video, all the applications related to the law of conservation of momentum now. So today we'll concentrate only up to the collisions now, right? So what is the momentum now? You will see in the other video. So after collision now, what will happen now? I already told, therefore here first ball will slow down, it will go with a speed V1, other ball it will go with a greater speed, so it will go out of this. You understand? No? In this way the collisions will take place. So to study these collisions, therefore here one more important point, this point, in any type of collision, whatever may be the different type of collisions we are going to study, in all the collisions conservation of momentum will be takes place. Compulsory this formula should be applicable for any type of collisions now. But what about the energy now? See, this having kinetic energy, this having kinetic energy. So when they are get collided, what will happen now when they are get collided now? So when they are get collided, so therefore sometimes heat will be generated, some sound will be generated, some deformation will be takes place now. So therefore suppose in some collisions energy will be lost. So some collisions, ideal collisions, so we'll assume that energy is not lost, right? So based on the energy, we'll have one classification, based on the direction. That means, so before collision in which direction is going, after collision in which direction, how they are going, based on that, so we also classify the collisions, So therefore, if they are going in the straight line after collision and before collision, so this is said to be like a head-on collisions, right? So head-on collisions now. So after collision, therefore if they are collided, right, if they are coming like this and after collision they are going in the plane in a different directions, so that is called as like a oblique collisions. Oblique collisions now. Here momentum conservation, momentum initial, right, it is a vector form, so along the x-axis momentum conservation should take place, if it is having y-axis also momentum conservation should take place along the y-axis also, you have to take it onto this. Okay. So based on if they are going before collision and after collision, said to be head-on collision, after collision, they are going in a different directions, that is said to be oblique collisions. right? So based on the energy conservation also we'll classify into different type of collisions. No, we'll classify this, right? Collisions, types of collisions. No, so what are the types of collisions now? So based on the direction we say that head on and oblique. Based on the energy, so we'll classify so into three categories. So what are the three categories now? Let us see here, right? So first, in any type of collision compulsory momentum conservation will be there. So first one is elastic collision. Elastic collision. So next one is inelastic collision. No, inelastic collision. Another one is perfectly inelastic collision. What are these types? No, we'll see now. So perfectly inelastic collision, we'll call it as like a completely inelastic also, both are same only, right? So here in the inelastic collision, I mean in the elastic collision, so all the collisions compulsory momentum conservation will be there. Initial momentum and compulsory final momentum will be conserved onto this one. No, therefore initial momentum and final momentum both it will be the same. Even this one, no, even this total initial momentum and total final momentum after collision, no, so it will be same. But elastic collision is there, no, here total initial kinetic energy and total kinetic energy final after collision kinetic energy. So before collision total kinetic energy will be the same. So kinetic energy same means what will happen now? There is no loss of energy. No loss of energy. No loss of energy means what? So while colliding there is no heat is generated, there is no sound is created, no anything, any form of energy is not lost onto this. So that type of collisions is possible in really. So therefore these type of collisions are not possible. So but ideally we can tell like collision between the air molecules is assumed to be elastic collision, and collision between alpha scattering experiment, no, alpha particle will come and reach to the near to the nucleus and it will get deflected. Understand? No? So here also in all the collisions there need not to be having any physical contact also is right. So collisions will take place on this, right. So therefore in elastic collision examples are what? Collision between air molecules, collision between alpha particle and nucleus, alpha scattering experiment, that are considered to be elastic collisions now, right. Inelastic collision, so in our day to day life, no, in our day to day life, so we will see all these type of collisions, no. So here initial kinetic energy and so final kinetic energy is not equal, that means definitely there is a loss of energy will takes place onto this. So that means maybe heat, maybe sound, or maybe any other deformation energy may takes place onto this one. Here, right, what is a perfectly inelastic collision means what? Perfectly inelastic means keep in mind that before collision they will be traveling different objects, no. Once they get collided they will stuck together and move like a single object. So that type of collision is said to be like a perfectly inelastic collision. In this also, therefore inelastic is there, no, kinetic energy initial is not equal to kinetic energy final, is not equal to kinetic energy final. Definitely in this inelastic means compulsory energy loss will be there now, right. And here we will discuss one more important one, that is coefficient of restitution. What is that coefficient of restitution? No, so we will define while we are discussing the questions, no, or concept, no. So coefficient of restitution, that here it will be equal to 1, and coefficient of restitution here E value lies between 1 and 0, right. So this will lies between 1 and 0, right. So here in this perfectly inelastic collision, no, coefficient of restitution will be equal to 0, right. So this coefficient of restitution indirectly it will gives us how much amount of going to energy loss, right. So like that you can keep in mind. We will give the definition for this one. So this is a basic type of collisions, no. Here compulsory energy loss will be there in this one, right. So energy loss compulsory will be there, right. So here there is no energy loss, right. We will see one elastic collision, no. Okay, head on elastic collision, head on, if a word is there, no, head on means before collision and after collision. So they are traveling in a straight line. Elastic means, so elastic, immediately you should get into your mind, that is so momentum conservation. Collision means momentum conservation, elastic means kinetic energy conservation, that's all. So you can write down this equation now. Here momentum conservation is a vector quantity. You have to choose one direction. No, suppose I am taking, this is a direction, the objects are going in this direction, taken as positive, the objects are going in the opposite direction, to be taken as negative. I am taking, this is my direction now, so this is going in the same direction, momentum conservation now. So initial momentum, total initial momentum, total final momentum, vectorially compulsory, very important. So initial momentum, therefore m1 u1 plus this also going in the same direction now, m2 u2. This is before collision now, right? So it will be equal to, after collision also both are going in the same direction now, m1 v1 plus m2 v2. So this is momentum conservation now. Suppose if these two objects are going in opposite direction onto this one, no, what you have to do, m1 u1 minus m2 u2, correct, like that. Now next one, kinetic energy conservation. Initial kinetic energy, half m1 u1 square plus half m2 u2 square is equals to half m1 u1 v1 square. So before, right, collision kinetic energy, and after velocity, after collision kinetic energy, v1 square plus half m2 v2 square. So if you solve these two equations, no, you will get one equation now. That equation is nothing but a so velocity of the separation, therefore velocity of the separation, these two are separating, no, v2 minus v1, velocity of the approach, so relative velocity of the approach u1 minus u2, right. So what will be the coefficient, these both are equal, no, what will be the coefficient of restitution, no. So coefficient of restitution, E value, this is equal to 1, that is nothing but a, so velocity of the separation, that is v2 minus v1 by u1 minus u2. Therefore this is the definition for our coefficient of restitution. Indirectly we can write down one simple word, right. So relative velocity, these are relative velocity of the separation, relative velocity of separation, right. So by relative velocity of approach, right. That means, so what will be the relative velocity, they are getting approach together, and with what relative velocity they are going out onto this one, right. So this ratio only will call it as like a coefficient of restitution. Very important, for NEET and JEE compulsory questions are asking, no, we will do the questions related to this, right, in the second part now, right. So now we will do, okay, you have to solve these two equations, no, then you will get it this one, no, then we want to write down the velocity equations v1 and v2, we want to calculate. See, generally if any question is given, if you write these two equations and solve it, is okay, fine, you can do it, no. Sir, I want to calculate a formula onto this one, no, means, so here I will give one small technique, no, please listen. So how to write it now, listen very carefully, very easily you can write it, no, velocity after collision v1. So what do you write it now, therefore it is u1 plus, listen carefully, again the same thing we will do it for inelastic collision also. So here 1 and 1 is there, so 1 and 1 means what, so here 1 and 1 same object, no. So you write down m1 minus m2, separate of these two masses by add these two masses, m1 plus m2. Here 1 is there, first one 1, here opposite are there, two different opposite, no? Therefore 2 m2 by m1 plus m2. Keep in mind. So how we are writing, no, just you try to practice once or twice, no, so that you will be perfect onto this. Now let us write down similarly v2, therefore it is u1 plus, therefore it is u2, right. So similarly here u2 v2 u1, so that means different means 2, here 1 is there, here 2 is there, 2 is there, therefore 2 m1 by m1 plus m2, clear. So here opposite are there, so what you can write it now, I am sorry, here same are there, so therefore here m2, here 1 1 1, here 2 2 2, therefore m2 minus m1 by m1 plus m2 Please observe very carefully. So how I written this one now, these formulas now. So observe. So you can once or twice now, if you practice, you can do it. So these are the velocities after the collision. Sir, I don't want to remember means please write these two equations, solve it. That's all. You can get your answer now. Clear? Right. Similarly, okay, remember this for solving the questions. No, we will use it. Right. Second one, head-on inelastic collision. Now, what is head-on inelastic collision? Now, head-on means going in a straight line. Right. Inelastic means so while colliding, no, while colliding, what will happen now? This will get collided and this will get collided. So therefore, definitely energy lost. Right. So energy loss. Here, whatever may be that energy loss doesn't matter onto this one. No? Here, we'll first of all you have to observe conservation of momentum. So momentum conservation, immediately you should get in your mind direction. So I'll choose this is my direction now. So whatever the objects are going in my direction, so I'll take it as positive. So here these two are going in my direction now. So m1, okay, immediately you can write it no, momentum conservation no, initial momentum, total initial momentum, total final momentum. Clear? So therefore here you can write down, therefore m1 u1 plus m2 u2 both are going in same direction. It will be equal to after collision also going in same direction. So m1 v1 plus m2 v2. This is equation we can write it now. Kinetic energy conservation we cannot write it. Why? Because energy lost. So how to do this one now? That is we have coefficient of restitution. What we know it now, coefficient of restitution, velocity of the separation. So velocity of the separation is what? So v2 minus v1, these two are separate because the speed is more. So velocity of approach u1 minus u2. Clear? So here it does not have, okay, use these two equations now, again write down v1 and v2. Okay, so here I am not going to derive any equations now, I will tell you how to write the equations here now, right? So listen carefully, exactly the same. So just a few minutes back we discussed now v1. What is the v1 now? Again, therefore it is u1 plus again it is u2, right? So v2 we written now, therefore again u1 plus again, so therefore u2. Clear? So we written now, here we written 1 1. What we written now? m1 minus m2 written now by m1 plus m2. Correct? So this is for elastic collision we written. Here 2 is there no, therefore here 2 is there, this is m2, so here 2 is there, so therefore m1 plus m2. Here 2 was there now initially, right? Here what 2 was there, m1, sorry, okay, m1 by m1 plus m2. Here same are there, m2 minus, therefore m1 by m1 plus m2. These are the equations we written for elastic collision now. Here in elastic collision we will write it now. One small thing, small change. Here 2 we will remove, here I will remove 2. Here we will write down. So one more important thing now. Here coefficient of restitution now. Here E. Here 2 are there now, 1 plus E. Here 1 plus E. Here m2 minus E m1. That's all. Clear? So in this way we can write down velocities after collision now in the inelastic collision. Clear? Therefore here you can use this one now and you can write down energy loss. How much amount of energy loss? How much energy loss now? How to write it now? Energy loss. Therefore here kinetic energy loss. Therefore here that is nothing but a kinetic energy initial minus kinetic energy final, that is total, right? So therefore total initial kinetic energy, final kinetic energy, how much is there? v1 v2. So you can simply we can write it now. So therefore if you know the u1 u2 v1 v2 all this one, then you can write it directly. Sir, I don't know, therefore you can, if you want to write it means I will give one formula 1 by 2. So m1 m2 by m1 plus m2 into 1 minus E square into u1 minus u2 whole square. This is your loss of kinetic energy. So slight important thing is there here now. What is this one now? Right? Right. So here one small important concept here, no, that is here u1 minus u2 is there, no. Here if two objects are going in the same direction, no, this is one. Suppose if the two objects are going in the opposite direction to each other, no, then here you will write down u1 plus u2, right. So that is only one condition, no. Rest of the thing, no, you can calculate. So the loss of kinetic energy, no. Clear? Now we will do one more, that is completely inelastic, no, or perfectly inelastic. Collision means immediately mind, that in mind you can get it, no, momentum conservation. Collision means inelastic, kinetic energy is not conserved, right. So here completely inelastic means what? After collision definitely they are going to move together, no, right. So here momentum conservation in any type of collision, right. So you can write down m1 u1 plus m2 u2. After collision they will be combinedly to move like a single entity. So therefore m1 plus m2 into v. So this it will be the common velocity. You can write down m1 u1 plus m2 u2 by m1 plus m2. Clear? So this is the common velocity. Suppose if they are going in same direction means what? So like this, if they are going in opposite direction, no. So therefore you will get it now m1 u1, but m2 u2 will be minus. Clear? So that you should be very careful, no. Here will become like a minus. So here what will be the coefficient of restitution? Coefficient of restitution will be equal to 0. Why it is 0? Because there is no here relative velocity of the separation now. Therefore here v2 is same, v1 is also same. v2 minus v1 is 0. So 0 by something is also, it will be 0. So completely inelastic collision, no, coefficient of restitution will be 0. So there will be energy loss will be there definitely. Inelastic means energy loss. So how to write it now? Again the same formula, just substitute E is equals to 0 in the previous equation now, right. So what is that equation? Energy loss in this one now. What is the energy loss? Half m1 m2 by m1 plus m2 into 1 minus E square is there, no, E was 0. So therefore 1 minus E square. So therefore it will be become like 1. So but u1 minus u2 whole square. Again the same thing, if they are going in same direction you can use this one, no. If they are going in the opposite direction, no, so definitely you have to take it as positive onto this, right. In this way you can calculate the energy loss in the perfectly inelastic collision now. Clear? Right students, I will see one application now. Here we can determine the speed of the bullet by using like a ballistic pendulum. So what is this ballistic pendulum, no? So suppose what you have to do, no, you have to take it as one string. So therefore here you are going to keep a one block, here block of mass capital M. Here it is suspended, therefore total length is it will be L to the center of gravity. So therefore here what you will do now, here we are going to hit with one bullet. We are going to fire the one bullet, right, to this bag onto this one now. Bullet mass is M, so this bullet speed it is U. So what will happen now? There are so many situations will take place, no. That is bullet will go and it will hit to this one, no, and it will be get embedded in it, or the bullet will come and it will hit and it will leave it. Okay. So first let us take one simple case, no, that is bullet will go and it will hit, so it will get embedded in it. So then what will happen now? Once it is get embedded in it, no, after collision, what will happen now? See, after collision what will happen? So here, so therefore here the bullet here, therefore here it is M and this is the bullet, both one. Now what will happen now? So this here initially there is a momentum is there for the bullet. After this one now both it will be able to move here. So this it will be able to move, therefore here, so the bullet and so this is block, therefore this you are going to raise to certain height here, height, right. So this height, you know, so if you determine this height or if you determine this angle, we can determine the speed of the bullet. How to determine the speed of the bullet now? So we will apply, here it is like a perfectly inelastic collision, no. So therefore here before collision and after collision, no, momentum conservation, therefore some small mu here it is not moving, therefore momentum is 0. So after that they are going with a some speed now, therefore it will be going with a suppose capital V. So what will happen now here, so capital M plus small m into therefore V. So V will be your the speed of this one, right. So it is having kinetic energy, therefore half m plus m into V square, therefore it will goes to height now. So m plus m into GH, this will get cancelled out now. So therefore if you determine the height, or you can write down V square is equals to 2GH. V is what we can write down, V is equals to small m by therefore capital M plus small m into U. Just substitute in this equation now. So substitute in this equation, okay. So therefore what you will get it now, small m by, okay, this we can one more thing now we can rewrite it as, so here V is equals to square root of 2GH. V is how much now, small m by capital M plus small m into U. So therefore U you can write it as, so capital M plus small m, this I am taking here now, divided by small m into square root of 2GH. This is your velocity of the bullet. If you remember the, if you able to measure the height of this one. Suppose if you are able to measure this angle, so what you can write it now, I taught this formula in the vertical circular motion, please see it now. So this height can be calculated as very simple, that is nothing but a length of this one now, L into 1 minus cos theta, right. If you know therefore cos theta, so theta, therefore you can determine the length now. So therefore by using this, if you can substitute in this one now, then you can able to calculate if you know this angle theta now, right. In this way we can determine the velocity of the bullet, right. So right, so this is in this way we can determine it now. Now suppose some situation it can takes place now, that is bullet will come and it will hit and it will go out. Therefore at that situation now what you can rewrite it as, so again momentum conservation, this only you need to write it now. So what will be the momentum conservation before collision now, mu, but this big block was 0, therefore after collision now this will be gaining capital M into suppose capital V, then afterwards the bullet speed it will reduce small m into U dash. So then by using this, right, so you can able to then we want V only, so then you can calculate V from this one now, then you can apply all these situations now, then you can determine the speed of the bullet onto this, okay student, right. So we will see some more applications now related to this, like bouncing ball is there, right. So height after first bounce, second bounce, velocity of the first bounce, second bounce, these all the things no we will study in the second part, and also some numerical questions how to do very quickly we will do in the second part, okay. Thank you for watching, please subscribe to my channel now. Thank you students.